This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 1. Thermodynamic properties and state. The foundation every other topic assumes. Medium yield, but you'll use it in almost every first law, second law, and cycle problem. Get the vocabulary right, and the next 10 videos get much easier. Here's the problem. A rigid 1 cubic meter tank holds 2 kilograms of water at 200 kilopascals. Find the phase, the quality of two-phase, the internal energy U, and the enthalpy H. Pure properties and state. No first law, no cycle. Every step is a lookup or a one-line weighted average formula. By the end, 2 minutes. A property depends only on the current state, not on how it got there. Pressure, temperature, specific volume, internal energy, enthalpy, entropy, all properties. Work and heat are not, they're path-dependent transfers. The rule: a simple compressible substance is fully fixed by any two independent intensive properties. Two numbers pin the state. Every state problem starts by asking, what two things are pinned? Intensive versus extensive. Extensive scales with mass. Double the system, they double. Volume, mass, internal energy U, enthalpy H, entropy S. Intensive is mass independent. Pressure, temperature, density, and the lowercase specifics, V, U, H, S. The convention is strict. Uppercase extensive, lowercase intensive. See a capital, mass is in the equation. See lowercase, you've already divided by mass. The TV phase diagram. Temperature vertical, specific volume horizontal. 3 regions. Compressed liquid left, superheated vapor right, two-phase mixture inside the dome. The dome is bounded by the F line, saturated liquid, and the G line, saturated vapor. The top is the critical point. Inside the dome, pressure and temperature are locked together, so to pin a state, you need a second property, like quality or specific volume. Outside, pressure and temperature are independent, and together pin the state. Setup. Specific properties are extensive divided by mass. V equals V over M. U equals U over M. S equals S over M. Enthalpy H equals U plus PV. That's the definition, and it's why tables list H directly. To go back, multiply by mass. Capital V equals M times V, and so on. Quality X is the mass fraction of vapor. 0 is all liquid. 1 is all vapor. In between is wet. Every specific property is the mass weighted average. V equals VF plus X times the gap, VFG. And the same for U, H, and S. The subscript FG always means G minus F, the gap across the dome. Memorize the structure, VF plus X times VFG, same pattern for all 4 properties, and you'll use it in half the problems you see. Build the variable table. 1 state column, single state problem. Pressure, volume, and mass are given. Specific volume comes from division. Temperature, quality, U, and H come from lookups and weighted formulas. Fill the given row, compute V, then phase check against VF and VG. That check tells you whether to weight by quality or go to a different table. Pattern recognition from the prompt. Saturated at a pressure or temperature. On the dome, go to the saturation table. Quality given, weight with X. Superheated at a pressure and temperature, superheated table, no weighting. Compressed liquid at a temperature, approximate as saturated liquid there, tiny error. And the classic phase check prompt, rigid tank, mass M, volume V. Compute specific volume first, compare to VF and VG, and that tells you the region and the formulas. Handbook quick reference. Property definitions and the quality formula are up front in Chapter 4. The steam tables come as saturated by temperature, saturated by pressure, and superheated, each in IP and SI. Today's problem is SI, so we use saturated by pressure. Both saturation tables list the same properties for F and G. The only difference is which variable indexes the table. Pressure given, use by pressure. Temperature given, by temperature. Solve. Step 1. Specific volume is V over M, which lands at 0.5. Step 2. Enter the saturation by pressure table at 200 kilopascals and read off VF and VG. Step 3. Compare. VF is less than V is less than VG, so we're inside the dome. The mixture is two-phase. If V had been below VF, it'd be compressed liquid. Above VG, superheated. Always phase check before assuming quality applies. Step 4. Invert the V mixture formula for quality. X equals V minus VF over the gap VG minus VF. That gives 0.564. The tank is about 56% vapor by mass. Step 5. Grab UF, UFG, HF, and HFG from the same row of the table. Keep them for the next step. Step 6. Apply the quality weighting. U equals UF plus X times UFG, which gives 1,646.6. H equals HF plus X times HFG, which gives 1,746.6. Quick head check. H minus U should equal P times V, and PV here is 100. Exactly the gap between them. Free verification that your table values are consistent. Final answers. Phase. Two-phase saturated mixture. Quality about 0.56. U is 1,647. H is 1,747. If the problem asked for extensive totals, multiply by mass. U is 3,293. H is 3,493. Always convert back to extensive when the problem asks for capital letters. Handing in specific values when the greater wanted totals is a free miss. 5 ways this loses points. 1. Skipping the phase check. Jump to the quality formula and you can get X above 1 or below 0, meaning the real state is superheated or compressed liquid. Absurd X means wrong region. 2. The subscript FG means G minus F, the gap, not VG alone. 3. The right saturation table. Pressure given, sat by pressure. Temperature given, sat by temperature. Cross-wiring gives 10 to 20% errors. 4. Don't mix units. Kilojoules and BTU don't add. Pick a system and stay there. 5. H already includes PV by definition. Don't add it again when H is tabulated. Quick recall. Divide by mass for extensive to intensive. 3 phase regions, 2 saturation curves. Saturation values VF and VG. Gap, VFG. In the 2-phase region, every specific property is the mass-weighted average with quality X, and any 2 independent intensive properties pin the state. Master this slide and you master topics 2 through 10. They all start here. Next up, topic 2, the first law for closed systems. Now that you can pin a state, energy balances become easy. We'll tie heat and work to the change in internal energy, and specialize for constant volume, constant pressure, and polytropic processes. Before that video, redo today's problem with V equal to 2 cubic meters. You'll find V equals 1, bigger than VG, so superheated. PEPrepengine.com/beta. The properties cheat sheet, the worked problem PDF, and a 5-question quiz are attached to this video. If the course helps you, subscribe.
The full study guide with every equation and common exam trap is free at PEPrepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.